Another video on the channel. In today's video we're going to be taking a look at question 8 from the 2020 Math Methods External Exam, paper 2. Now you would have noticed with all the videos on the channel I've started dividing all the questions up into individual videos. That way if you only struggle with certain questions you can go watch those ones. And if you have any questions at all during the video, just leave something in the comments. The link to the full exam video is still up on YouTube. It's in the description below. And if you guys need a Methods External Exam bundle pack, the link is also in the description below. So get your download pretty quickly. Okay. So question 8. Determine the size of angle A in the triangle. So this one here is a pretty easy question. All we need to know is what rule to use. So when you have a triangle, you could use the sine or the cosine rule pretty much. Now, if you have 3 sides and no angles, it's best to use the cosine rule because it has all the sides and an angle. So for example, if we have, in this case here, 1, 2, 3, we have 1, 2, 3, 4, 5. We have all of those terms there because 2 of them are double ups. And we can solve for an unknown angle here. The only thing is, a lot of people may not know how to rewrite this formula. They're asking for angle A, yet are forming the set for angle C. So all we have to do is swap the A and the C around. So wherever the A appears, we're going to replace it with a little c, and wherever the big C appears, we place it with the big A. So for example, we're going to swap A and B, A and C in this question. So here, we'll write as A squared equals C squared plus B squared minus 2CB. I will write that as a lowercase, just a habit of writing as uppercase because they look like 6s otherwise, and then cos of A. Now we've rewritten the cosine rule in terms of our question here. So here we can recognize that little a is 8.8. Little c here is 11.3. So I'm going based off those sides there because that's big A. So little a would be this one, little c would be this one, and then little b would be that one there. So little b is 9.9. Now all we have to do is rearrange to get the angle by itself. So that means pretty much moving everything. So I'd move the c squared and the b squared across by subtracting them. So you get something like this. Then you would divide both sides by it. So you get a squared minus c squared minus b squared over negative 2cb equals cos A. Then I would actually just start chucking in all the stuff pretty much. Okay. So here, wherever these guys appear, replace that in there, and we'd actually calculate what this is actually going to give us. Now what I'm going to do is I'm going to move this out the way because we're going to run out of room otherwise, and move this guy up there. So in your calculator you'll be chucking in 8.8 squared minus 11.3 squared minus 9.9 squared over negative 2 times 11.3 times by 9.9. Okay, so we'll just do that very quickly. If they ask you for a cosine, the cosine would be this thing we're calculating here because it's the ratio of adjacent over hypotenuse, which is cos. So here, if they ever ask you for that, just know that would be this thing we're calculating here. So this gives us 0.6626 roughly. So that's cos of A. So to get the A by itself, you cos inverse this thing here. Now I'm going to leave my exact answer in the calculator. That way it gives us the most accurate one. So cos inverse of shift answer. So here we get, now make sure you are not in radians because I'm in radians at the moment. Make sure you're in degrees. So here I get 32.17 roughly for A. Now here, I know what you're thinking. You're looking at these guys here and you're just thinking, oh, that matches none of them. So what we do in this situation here is we double check, okay, do we have a complement there at all? So for example, if I were to minus, let's say, 180 from any of them, will I get the correct answer? But the first thing I would be checking straight away is, have I written the formula correctly? So we have a squared equals b squared minus, so a squared, actually I'll just write the normal one first. C squared equals a squared plus b squared minus 2ab cos c. So here when I swapped this stuff around, always double check this because this can happen. So I had a squared equals c squared plus b squared minus 2cb cos a, and yep, that's still correct at the moment. So everything we've done is fine. Now we're going to check our substitutions. Did we do that correctly? So that would have gone in there, just that one. This would have gone just in there, and then this again would have gone in there. Yep, so we've done everything correctly at the moment. What I would do is just recalculate all the numbers to see if anything doesn't work. I would just recalculate everything. So 8.8 squared minus 11.3 all squared plus or minus 9.9 squared, negative 2, 11.3, and then 9.9. Yep, so we still get that one there, and we still get this, and then we go cos inverse, shift answer. Okay, not sure what would happen there, so I just put in my calculator again. It's just given 48 now, 48.49 instead. Must have just been a miss button click then. Okay, so here the closest answer to that would be A then, because we got 48.49, and that's 48.5. So A is your correct answer. I'm going to keep that in the video actually. That's a good thing to double check because I can get that wrong and so could anyone. If you have any questions about this one here, you need to take a look at trigonometry a bit better, specifically sides of triangles. If you need a practice external exam for methods, the link is in the description below to get your download. And if you need any help at all or a consultation, just send me through an email or just write something in the comments and I'll try my best to answer it. But otherwise, I'll see you guys in the next video.